Hi, I'm Lee, and this is NASA Now. The launch of the Space Shuttle is just a short time away. During today's program, we'll hear from a NASA engineer who works on the shuttle's guidance, navigation, and flight control systems, called GNC. And we'll find out why 3 is an important number for calculating the location of the shuttle in space. But first, let's find out what's happening at NASA Now. NASA's newest Earth-observing satellite mission is called Glory, and it's scheduled to launch from Vandenberg Air Force Base in California in February. Glory's mission will help improve our understanding of how the sun and tiny particles called aerosols affect Earth's climate. The mission also marks the first satellite launch under President Obama's climate initiative. When the shuttle mission STS-133 launches in February, it will be headed to the International Space Station, where it will deliver an external platform. The platform holds large equipment and spare components. The shuttle will also deliver Robonaut 2, or R2, the first human-like robot in space. Now, let's take a look back at the past.
April 12, 1981. Almost 30 years ago, we celebrated the maiden launch of the first flight of the Space Shuttle Columbia. The shuttle orbited the Earth 37 times during its mission. The primary purpose was to check out the overall shuttle system and have a safe ascent into orbit and a safe return to Earth. Mission accomplished.
NASA's next shuttle launch is approaching, and we're lucky to have George Hatcher, a GNC engineer. GNC stands for Guidance, Navigation, and Flight Control. Let's listen and watch as Mr. Hatcher explains the technologies used to locate, guide, and steer the shuttle in its flight to and from the International Space Station.
My name is George Hatcher. I'm a Guidance, Navigation, and Flight Controls engineer. Navigation is basically where am I? Guidance is how do I get to where I want to go? And Flight Controls is how do I change the direction that I'm pointing as I move through the atmosphere? Because the shuttle takes off like a rocket and orbits the Earth like a satellite and then returns to Earth through the atmosphere like an aircraft, we actually have to use different control devices in different ways. One of the ways that it measures its position is through 3 different boxes that we call inertial measurement units. Inside these boxes we have 3 gyroscopes. They're sophisticated devices that basically allow the platform inside the box to maintain its orientation even though the vehicle moves around it. And we have 3 accelerometers. And the reason I'm making this symbol with my hand is because we put the accelerometers on individual axes. They're called orthogonal axes. That means that they're 90 degrees away from each other. And then from the moment that we launch, they start measuring the accelerations in those 3 axes. And then they have the position so that they can provide that display to the astronauts to say, this is the point where you are in space. We have sensors that are on the devices that the astronauts manipulate. And the sensors provide a signal to the general purpose computers, which are kind of like the brain of the spacecraft. There are certain things that can cause the solution that they provide to the general purpose computers to drift from reality. One of the ways that we can compensate for that error and correct it is through what we call star trackers. And these are cameras that are behind heat shields. And when we open those shields up and allow those cameras to watch the stars, there's a database inside the computer that can match what the camera sees to a known star chart. Once it matches that, it can tell the inertial measurement units, this is your exact orientation in space. When we get to orbit, we still need to know what point we are above in terms of the surface of the Earth. And we need to know where the International Space Station is if we're going to dock with it, and how far we are from it, and how to get there. When the shuttle is on orbit, they have the ability to change the roll and the pitch and the yaw of the vehicle with that rotational hand controller that they use when they fly it like an aircraft, they also have what's called a translational hand controller. And that makes the shuttle translate either forward and back, or side to side, or up and down. There are close to 100 electronic boxes that do specific functions that are associated with GNC to get it to go where we want it to go.
Today we learned that guidance, navigation, and flight control are critical to the successful operation of the Space Shuttle. Here's your chance to use imagination. You and your classmates are going to build a Space Shuttle glider. To get started, check out the resources and activities on the NASA Explorer School's virtual campus. Well, that's it for NASA Now. Be sure to tune in next week when we learn about the GLORY satellite and the important role it will play in the study of Earth's climate. We'll see you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.